So we are now done with our notes about sort of ecology in general. And what we're going to start talking about are some ways that humans affect the earth and its ecosystems. So in general, if you think about this, how do humans affect the earth? What kind of impact do you think we generally have?
Like if they dig, make a hole.
Yeah? Pollution?
I was going to say pollution.
Pollution. Do we have generally a positive or negative effect on Earth's ecosystem? Generally
Well,
negative.
We plant flowers.
Yeah, it depends. But overall, okay, often humans have a negative effect on our ecosystems that we live in. And so the question is why? Why do humans have such a huge impact on the Earth? Well, one thing is we can alter ecosystems to a degree that no other species can. We can take a forest and, clear cut it, bulldoze it, and build, plant grass and completely transform the ecosystem. We can take a desert and build a city there where really there should be no city because there's very little water. But we've done that. We built Las Vegas. And we can alter our ecosystem to a great degree. The other important thing is about our population. How many people live on Earth?
Too many. About 7 billion.
Yeah, 7 billion. That's a lot of people. And those 7 billion people, they need certain things. They all need food. They all need water. They all need a place to live. And so that requires a lot from the earth. But also, not only that, they want certain things. A big house, a car, okay, a phone. And all those things also require a lot of resources. And so you can sort of trace back many environmental issues to there's just a lot of people on the earth. And they need a lot of things from the earth. And that leads to some of this damage that we're going to be talking about. So 7 billion people live on the earth. That's a lot of people. This little video clip is meant to give you an idea about what that means. Because it's kind of hard to visualize 7 billion. see there, just get some kind of conception about what 7 billion people is. And it's a lot of people. So all those people, like we said, they need certain things from the earth. Okay? And we call those things resources, natural resources. And so those things that we get from the earth, those natural resources, we kind of put them in 2 categories: renewable resources and non-renewable resources. So some things we take from the earth, we call them renewable. Or some things we use to make electricity are renewable. What does that word mean? What is a renewable resource? Tyler?
You could use it like over and over.
Yeah, it doesn't get used up. It's replaced over time. It's replenished. Can you give me an example? What's something we use to make electricity that's renewable? Destiny?
Wires,
What's that?
like cables and wires.
Yeah, but that's how the electricity gets to our house. But like, where does it come from? Like, what's a renewable way we make that electricity?
The sun.
Well, we don't get it directly from the sun. What do we use? Solar panels. So we have solar panels, and they're becoming very common now. See them on houses. They take the sun's energy and turn it into electricity we can actually use. Is the sun replaceable over time? Does it get used up? No, it's always there. Okay? You're not going to use up the sun because you put some solar panels on your house. What's similar to solar power? Another way we can make electricity. Avery? Wind power. You've seen these huge turbines? They, by using the wind to turn the blades, which turns a turbine inside, and that makes electricity. Again, that's renewable. We're not going to use up the wind. It's replenished over time. Water power, same thing. Food that we grow is a renewable resource. We could grow it year after year as long as it's done in a sustainable way. So those are examples of renewable resources because they're not getting used up. They also, wind, solar, hydroelectric, are much less safer for the environment. They don't release pollution like some of the other sources do. So what are some well, first, what does non-renewable actually mean?
You can only use it once.
Could only use it once. Once you use it or burn it, it's gone. It's used up. It's not coming back. So what are some examples of non-renewable resources we use? Bella? Oil that we pump out of the ground. We use it to make gasoline. That's non-renewable. When you take a gallon of oil out of the earth and burn it, it's gone. It's not going to reform. It's used up. Madison? Coal that you dig out of the ground. Sometimes some of our power plants that make electricity are powered by burning coal. And again, you dig some coal out of the ground, it's gone. It's used up. Natural gas that we use in our homes. That's another example of a non-renewable resource. We call those things fossil fuels because they came from ancient forests that were buried underground and eventually became these fossil fuels. But they're gone. Those forests are no longer around. We're not going to make any more of these fossil fuels. Abiel?
Couldn't water power be non-renewable at one point?
No, it's pretty much renewable because water is recycled in the earth. It's never really used up. Also minerals, metals, things that we sort of dig out of the ground to use, those are non-renewable. If you dig a pound of platinum out of the ground, it's gone. It's not going to reform. So some pictures to give you an idea. These wind farms, they generate electricity through wind power. They're becoming pretty common. I saw them this weekend. I was traveling south down near Hamilton, New York, around Waterville, and you see big groups of these wind turbines with the blades thing. They're really big. You know, they look, usually you see them off in the distance and they don't look that big, but actually, I once saw a single blade from one of these turbines coming down on the thruway. It was being carried by a tractor trailer. And it's so big, it filled up the whole back of the tractor trailer. It was just one blade
Yeah,
of a
they're
turbine.
like 30 feet long.
Yeah, they're huge. This little video, it's kind of hard to see, but it'll show you the scale of one of these turbines. You can see there's a person way at the bottom here. Look at the height of this person compared to the height of that whole wind turbine. They're really huge.
Can't you go full screen?
Can you zoom in?
Yeah, I guess I'll full screen. So yeah, that person rode their snowmobile to this turbine, and it's obviously really, really big.
No, they won't.
All right.
Oh, like one of those blades though, like 30 feet.
Yeah, one of the blades is 30 feet. So those are renewable resources. Here are some non-renewable resources: coal, and oil, natural gas, coal, crude oil. These are all things we dig out of the earth, and basically they're gone. Well, for those non-renewable resources, there's a limited supply of them. We only have so much coal in the ground, so much oil, so much natural gas. So some ways that we can help preserve those limited quantities. I'm sure you've seen this before in elementary school, the 3 R's, right? Reduce, reuse, recycle. It tells us about how we can preserve resources. When we say reduce, we mean basically just use less of something. You know, buying products that have less packaging. Walking somewhere, taking a bike rather than driving somewhere. Driving with somebody, carpooling, taking public transportation. Using appliances that are more efficient, like you ever see like an Energy Star appliance, like your refrigerator might have an Energy Star logo on it. It means that it's designed to use less electricity to keep your food cold. Okay?
So that means we can drive a bike with it. Just goes down here.
It would be better for the environment. I don't know if you're allowed to. Reusing things. You know, every day to school I bring my coffee mug, right? So I'm not buying a paper cup at the store or anything or styrofoam. So I don't need to use more resources for my coffee. I fill up this water bottle every day. I never buy plastic water bottles in my house. I hate them.
Why?
Because
What is that?
they're wasteful. Because first of all, the water in it is no better than water that comes out of your sink. Second of all that plastic that you throw away or recycle is bad for the environment. When you could just have a water bottle that you fill.
Yeah, but doesn't the water bottle cost money?
It does cost money, but I use this how many times? I've used this for 3 years, and I bought one single water bottle. Rather than buying one of those huge, gross cases of water every week or whatever. So
You're vegetarian.
anyway, those are things to think about as we purchase certain things. Using products that last a long time rather than having to be thrown away all the time. Recycling is sort of the last option. You know, if you do have a plastic water bottle that you use, a disposable one, when you're done with it, you recycle it. At least the plastic that it's made out of can be turned into more plastic through recycling, and it's not going into a landfill. You know, melting glass, you recycle glass bottle or paper, you throw it in the recycling bin in your house, that gets made into a new product. So it saves some of the resources that would have been used to make the new one.
Okay, you want me to recycle some?
And I was going out that the on the packet that asked me.
No worries about that. So, a lot of people I found in talking about this with 7th graders is that you have the wrong idea about acid rain. So I know you've heard of acid rain, but what people tend to think is that like if it's raining outside and it's acid rain, like you're gonna be hitting you and it's gonna be like melting your skin, it's gonna hurt, you're gonna feel it. That's not what acid rain is. I know when I say acid, you guys probably are thinking of, it eats through, concrete and it dissolves your skin. And there are strong acids that can damage your skin, okay, or can eat through materials, but that's not what we're talking about. The acidity of something is just like a property, like its temperature. I can measure the acidity of my water in here, and it'd probably be right around 7, which is considered neutral. If I measured the pH of my coffee, it would be acidic. It might be, 5 or 4.5 pH. So acidity is just a property of a liquid that we sometimes measure. And it's measured by a scale we call the pH scale. Neutral is 7. So pure water has a pH of 7. It's not acidic at all. You can see here, normal rainwater is a pH of about 5.6. It's a little bit acidic because it has carbon dioxide mixed in it. Wine is acidic. Lemon juice, orange juice, coffee are acidic. Battery acid is very acidic. That is one that could damage your skin if you got it on you. You know, strong hydrochloric acid. There are acids that are damaging. But when we talk about acid precipitation, what we're talking about is that sometimes when we burn certain fuels that have nitrogen or sulfur in them, coal often has nitrogen and sulfur. When that sulfur and nitrogen gets into the atmosphere, it mixes with water and it forms acid. Acids that make the pH of the rain less than its normal pH. Okay? And what happens is that rain doesn't hurt you. You would never know. If you're walking out and the rain is acidic, you would never know it. But all of that rain falling onto forests and ecosystems, building up in ponds, it changes the pH of them. It makes them acidic. And that can be damaging to the ecosystem. It can damage trees. It can kill organisms living in lakes. There are some lakes in the Adirondack Mountains that are so acidic, nothing really can live there. They're called dead lakes. It's especially a problem in the spring, because all winter long, acid precipitation in the form of snow is building up in the mountains. And then once spring comes, it all melts, and all of that acidic water flows into streams and lakes at the same time, causing the pH to drop very quickly. And this graph shows that some organisms can't tolerate those conditions. If you look, this is normal pH, 6.5 is pretty close to neutral. And all of these organisms can survive. But if the pH of this lake drops, once it gets to 5.5, which is slightly acidic, well, these mussels, they can't survive those conditions anymore. So they die off. And obviously that affects the ecosystem. If the pH drops down another notch to about 5, now the mayflies, the bats, they can't survive those conditions. And as we keep going, just a type of insight, as we keep going down in pH, becoming more and more acidic, fewer and fewer organisms can survive. If we get to an extreme of 3 or so, nothing can really survive living inside of those conditions. So obviously, acid rain can damage the ecosystem and interfere with the food web.
Wait, are really there's like those little black things that
Yeah.
dive down the water?
Yeah. This is a map, obviously, of the United States. The dark orange shows areas where acid rain is the biggest problem. So where is acid rain the biggest problem? Where we are, exactly. The Northeast, Eastern United States. That's where acid rain is a major problem. It's a major problem in the Adirondack Mountains in our area. And part of the reason is because, have you ever watched the weather on the television, on the news? So what happens, when you watch the weather on the news, you have these big, storms. Which way do they move in the United States, if you're watching? Right. They go from which direction to which? If you're watching the stream left to right, which is usually west to east, right? The storms come across the country. Well, that's the way the prevailing winds in our area go. They go from west to east. So the pollution that's put in the air in the Midwest, where factories here, that gets blown over sort of to the northeast. And when it falls as acid rain in our area. So oftentimes the pollution that we see is not due to us, it's due to other areas. Here you see a spruce forest. They're vulnerable to acid rain. They can't tolerate acidic conditions. So those are some of the first forests to die off when there's a problem with acid precipitation. Here you can see the tree growth rings that as time went on, this tree grew less and less. If you've ever walked through a cemetery, if you've ever noticed the whitish colored gravestones, and sometimes the lettering has been worn away, have any of you guys seen that?
Yeah.
Those are made of limestone. And limestone reacts with acids very easily. So that's why they get worn away so quickly. This is a statue. native limestone. In 1908, it looked, you could see all the features, but in 1968, the same statue, all of the features have basically been eaten away by acid rain. So one of the reasons the Statue of Liberty was tarnished and had to be cleaned recently is because of the effects of acid rain.
It was clean.
Seriously?
Yeah.
No, wasn't
Wait.
it gold?
Yeah, it was copper color. So that's acid precipitation.
Smog.
Another important environmental problem is smog, not SMAUG, not like the great like smog from Lord of the Rings.
Oh my God.
But smog, SMOG. So smog, the word comes from a mixture of two words. Can you guess which two words? Going?
Smoke
No, not quite.
and
Fog.
Smoke and fog, yes. So fog, what is fog? When it's a foggy day, what do you see? Avery? It's clouds. It's basically water moisture. Smog, though, is not. Smog is a mixture of that water with pollution. Certain types of pollution react with sunlight and form a toxic gas. And that's what smog is. It's bad for us. It's bad for our lungs. People that have asthma, it can induce asthma attacks. And it's a major problem in certain areas, especially like low-lying areas with a lot of cars. A city like Los Angeles has a problem with smog because it's kind of in a valley. There's a lot of cars in that area, and so
and
these gases
China.
build up. Here's Beijing, China.
Yeah.
This is a day when the wind cleared out the smog. You can see the city. This is a day when it did not, and so this is smog. This is pollution. And in places where this is a problem, in the morning they might, along with the weather, they might give a smog index. And certain days there may be a smog warning saying, okay, the smog levels are so high, don't go out and go running and exercising outside because you're going to inhale too much of this gas. So you have to be aware of it in those areas. It comes from, again, burning of dirty fuels, and it can result in some respiratory problems. So how can we sort of address this problem? So what could you do to sort of help? Yeah?
Don't they wear like masks over their mouth?
Yeah, but that doesn't really help the problem, right? It might help prevent some of the irritation from the smog. Avery? By using other types of fuel, using electric cars, which are becoming more and more common. That electric cars don't produce any of this pollution as they're running. Only gasoline cars do. We can reduce the emissions from these cars. We can reduce the emissions from industries so that they're producing less of these toxic gases. We can use more renewable solar and wind generated electricity than burning of coal and so forth. All right, and one last issue we want to talk about is about the ozone layer. Has anyone heard of the ozone layer? What does it do? Sort of. Avery?
Something's flying.
Yeah. What does the sun give off that can be harmful to us? What type of radiation? It's called ultraviolet radiation. So ultraviolet radiation is released from the sun along with visible light and heat. And the effect of that ultraviolet radiation, it's what gives us a suntan. It gives us a sunburn. And over the long term can give us skin cancer. Okay? It can result in eye cancer, cataracts. And so ultraviolet radiation is harmful. It's why going to a tanning bed is not a good idea. Because a tanning bed is basically shining ultraviolet rays on yourself. That's why I go for a spray tan. That doesn't use ultraviolet radiation. So ultraviolet radiation is bad for us.
Really?
The ozone layer, this layer of a special gas called O3, instead of O2, it's O3, is really high up in the atmosphere, almost to space.
It's like,
And it allows, what it does is as the sun comes into the Earth's atmosphere, the ozone layer filters out much of the ultraviolet radiation, so less reaches us. So that's good. But there's a problem. What's happening, or what has happened to the ozone layer?
It can't like hold this much.
Not quite.
Can't hold it.
Okay? Anyone?
Pollution, like burns holes in it kind of.
Yeah, there is a certain pollutant called chlorofluorocarbons, CFCs. These are chemicals we used to use a lot of. They were in all aerosol cans, spray paint, hairspray, shaving cream. The stuff in there that would send the product out, the propellant it's called, used to be made of these CFC chemicals. And what happened is when you were using, your hairspray, these CFCs were released. They worked their way high into the atmosphere, and they start to break down the ozone layer. And they made it thinner. In some areas, like around Antarctica, there was a complete hole where it was completely gone around Antarctica. And the thinner the ozone layer is, the more ultraviolet radiation that can reach the Earth. And that's bad. It leads to more skin cancer, eye cancer. It can kill plankton, which are the base of the food web in the ocean. It can have a lot of negative effects.
But it replenish itself.
Yeah, it can. So Isaiah just asked a good question. Can it replenish itself? And it can somewhat. But what happened is that in around 1988, after this problem was sort of discovered, countries from around the world got together and came up with an agreement in Montreal. It's called the Montreal Protocol. They said, okay, these chemicals are damaging the ozone layer, this is a problem, and they agreed to limit the use of CFCs. Okay? And when you use a can of hairspray today, the propellant is not made of CFCs anymore. It's still found in refrigeration systems, in air conditioners, but it's not as common. And we have seen that the hole in the ozone layer has kind of leveled off. It's not getting worse because we've stopped a lot of the use of these CFCs. And what scientists are hoping is that it starts to repair itself, because the atmosphere can regenerate new ozone to fill in those gaps. And so hopefully that's what we'll see in the coming future. So ozone depletion is another important environmental issue. I guess let's save global warming. We'll finish that one tomorrow. That's our last environmental issue to talk about. And we will work on our review and we'll talk about the quiz tomorrow.
If we continue using,
Excuse me?
if we